The DuPont Company of Wilmington, Delaware, was founded in 1802 as a gunpowder manufacturer. By the early 20th century, DuPont had developed into a major chemical company and is today one of the largest chemical manufacturers in the world, with some 58,000 employees across 80 countries. DuPont has had a stated focus on accident prevention since its early days producing explosives. Over the years, DuPont management tried to drive the injury rate for workers to zero through improved safety practices. Eventually, DuPont became recognized across industry as a safety innovator and leader.
911.
Yes, ma'am. My name's Deborah Stanley. I'm at the DuPont plant in Vail, West Virginia. I need an ambulance immediately.
But DuPont's safety reputation was shaken in January of 2010. When 3 separate incidents occurred within 33 hours at the company's manufacturing plant in Bell, West Virginia, the last one fatal. The first involved an ongoing release of methyl chloride from process equipment that went unnoticed for 5 days. The following morning, highly corrosive oleum was released through a hole in process piping, and just 6 hours later, a transfer hose ruptured, releasing highly toxic phosgene.
Given the company's reputation as a safety leader, the Chemical Safety Board was especially concerned about this quick succession of 3 accidents at a major DuPont facility. Particularly distressing was the fatal release of highly toxic phosgene.
DuPont's Bell, West Virginia facility occupies more than 700 acres along the Kanawha River, 8 miles east of Charleston, the state capital. The plant produces a variety of chemicals. On January 17, 2010, 1 production unit was started up after extended maintenance. Methyl chloride produced in a reaction vessel flowed through an open rupture disc and escaped from an improperly located drain hole. The hazardous gas vented indoors in an area not frequented by workers. 5 days later, on January 22nd, an air monitor alarm inside the building alerted personnel of the release. Approximately 2,000 pounds of methyl chloride had escaped.
When the rupture disc burst, an alarm was triggered. But our investigation found that due to a history of false alarms, operators came to view this alarm as a nuisance that could safely be ignored.
The following day, plant operators discovered another release. Oleum, a concentrated form of sulfuric acid, had over time corroded piping in the plant's spent acid recovery unit. Steam from an attached copper tube mixed with the oleum and created a large hole in the pipe. Oleum escaped through the hole and formed a vapor cloud, discovered by workers shortly after 7 a.m. on January 23rd. Approximately 22 pounds of oleum was released.
The CSB found that DuPont had a previous oleum leak, resulting in a company recommendation to conduct regular maintenance inspections of the oleum piping. But the CSB found this was not done due to ineffective communications between DuPont and its inspection contractors.
The third in the series of accidents at the Bell plant came just 6 hours after the oleum release, and it would prove fatal. It involved phosgene, an industrial chemical so toxic it was used as a chemical weapon in World War I.
Phosgene severely damages lung tissue. This can result in a deadly buildup of fluid in the lungs, which may not appear until hours after exposure. The Bell plant's small lots manufacturing unit purchased phosgene in 1-ton cylinders from an outside chemical company. The plant used the phosgene to manufacture 5 different pesticide intermediates. The cylinders were stored in a 1-story, partially walled structure called a phosgene shed, which was open to the atmosphere. During use, the cylinders were connected to other equipment by flexible braided stainless steel hoses. Inside each hose was a liner made of Teflon, or PTFE. One hose used nitrogen to pressurize the cylinder, pushing the liquid phosgene into the manufacturing process. An electronic scale recorded the weight of each cylinder. And when it was nearly empty, an alarm sounded in the control room. An operator then closed valves to the empty cylinder and opened valves to a second, full cylinder. The stainless steel hoses to the empty container were purged of phosgene with nitrogen. The empty cylinder was then replaced with a new one on the weigh scale. On the day prior to the fatal phosgene release, operators were experiencing flow problems with one of the hoses and began switching between cylinders to avoid disruption to the chemical process. In the course of switching cylinders, the valve was closed on a partially full cylinder. However, the hose was not purged, allowing pressure to build as the liquid phosgene inside warmed up. Sometime between 1:45 and 2 p.m. on January 23rd, a worker was inspecting one of the cylinders when the pressurized hose suddenly burst. He was sprayed across his chest and face with a lethal dose of phosgene. Another worker was exposed to the deadly gas, and a third was potentially exposed, but neither reported any symptoms. A total of 2 pounds of phosgene was released to the atmosphere. Small concentrations of the dangerous chemical were detected by monitors at the plant's fence line. The worker who had been sprayed with phosgene called for help and was transported to a local hospital. 4 hours later, the worker's condition began to deteriorate rapidly, and despite medical treatment, he died a day after the accident. The CSB found the permeability of the transfer hoses to phosgene was a key factor in the accident.
During our investigation, we found that the PTFE-lined stainless steel hoses in use at the Bell plant are particularly susceptible to failure when using phosgene. That is because the phosgene can seep through the permeable PTFE lining and corrode the stainless steel.
We also learned that another phosgene hose nearly failed in the same manner and was discovered just hours before the fatal phosgene release, but this did not prompt an investigation.
DuPont's standard operating procedure requires replacement of hoses in phosgene service every 30 days. However, by the day of the accident, January 23, 2010, the phosgene hoses had not been changed in over 7 months. The software used to manage maintenance at the Bell plant had been modified, and it no longer notified operators when to replace the hoses. As a result, the hoses remained in use much longer than the prescribed service life. Documents obtained during the CSB investigation showed that as far back as 1987, DuPont officials realized the hazards of using the braided stainless steel hoses lined with Teflon or PTFE. An expert employed at DuPont recommended the use of hoses lined with Monel, a strong metal alloy used in highly corrosive conditions. The DuPont official stated, "Admittedly, the Monel hose will cost more than its stainless counterpart. However, with proper construction and design so that stresses are minimized, useful life should be much greater than 3 months. Costs will be less in the long run, and safety will also be improved." But the CSB found that the Bell plant never followed the recommendation to install the more durable Monel hoses. The CSB determined there are safer ways that DuPont could have run its phosgene operation. For example, phosgene cylinders should have been kept in an enclosure equipped with a ventilation system and a scrubber. If the enclosure were designed for human entry, workers should have been required to wear fully encapsulated protective equipment. Documents from 1988 show that DuPont considered building an enclosure for the phosgene operation, but then decided against it. One DuPont official wrote, "It may be that in the present circumstances the business can afford $2 million for an enclosure. However, in the long run, can we afford to take such action which has such a small impact on safety and yet sets a precedent for all highly toxic material activities?" DuPont decided not to enclose the phosgene unit at that time, but the potential for a deadly release remained a concern. The danger was noted in a 2004 process hazard analysis, which recommended constructing an enclosure equipped with a scrubber. Originally, the enclosure was scheduled to be completed by December 2005, but the deadline was extended 4 times and still had not been met in January 2010, when the fatal phosgene release occurred.
Without an enclosure around the phosgene operation, no barriers were present to prevent phosgene from exposing operators or traveling off-site.
Industry groups have established various good practices for the safe handling of phosgene and other highly toxic materials in compressed gas cylinders. The CSB found that the most comprehensive guidelines are those set forth by the National Fire Protection Association, or NFPA.
The CSB recommended that industry organizations such as the Compressed Gas Association and the American Chemistry Council adopt the more stringent guidelines of the NFPA for the safe handling of phosgene and other highly toxic gases. And the CSB called on OSHA to update its compressed gas safety standard to include modern safeguards for toxic gases. The CSB recommended these improved safeguards include secondary enclosures for units using phosgene, mechanical ventilation systems, emergency phosgene scrubbers, and automated audible alarms.
We found that each of the 3 serious incidents at DuPont's Bell plant was preceded by another event or series of events. However, these early warnings and near misses did not result in action to prevent them from recurring.
The CSB recommended that the DuPont Bell facility revise its near-miss reporting and investigation policy to emphasize anonymous participation by all employees so that minor problems can be addressed before they become serious.
The incidents at DuPont show that tragedies can occur even at companies with highly regarded safety cultures. Safer practices and proper attention to near misses are critical if a company is to reach a zero-incident goal, such as the one to which DuPont aspired. Thank you for watching this CSB safety video.
For more information on the CSB's investigation into the accidents at DuPont, please visit csb.gov.